Okay, good afternoon guys. So what are we up to today?
Alright boss, we gathered some information about how our organization's been doing the past year and we were thinking to let you review it.
Okay, let's proceed.
Lillard, a chance to send the Thunder home. Lillard, long range three, and it's good!
Damn, our guys are doing not bad. You've done a great job, guys.
So yeah, their performance is attracting a huge crowd and it's honestly our main source of income.
What about the women's side?
Okay.
What the heck is this? Why is the crowd so small?
Alright, sorry boss, I'm not sure myself, but we talked to a few people in the stands and they said that the biggest problems is the girls are not landing their shots, and because they're not landing their shots as often as the guys, the games are not as exciting, so they draw lesser crowds.
But why are the women not making shots?
How about we run an experiment? Since Glendon believes that males shoot better than females, our alternative hypothesis will be average shots made per 10 for males minus average shots made per 10 for females is more than 0. We will be sure to use a sample size of 30 or more so as to adhere to the central limit theorem and ensure that our results are more representative of the entire population. We recognize that there are some variables that we cannot control, such as timing, home ground advantage, and temperature, and these may affect our results. Hence, we will be sure to set the significance level to 0.1 so as to not incorrectly reject our null hypothesis.
I was waiting all week, so boring. But tonight I'll go out because it's Friday night. I wanna keep moving all night. I wanna dance all night.
So, what are your findings?
Okay boss, we went down to the course to collect our data yesterday. To ensure consistency, we had everyone shoot from the free throw line, which is a designated 16 feet away from the hoop. We then created two vectors to store our data, one being female sample shots and the other being male sample shots. So for this exact data point here, this particular male made 3 shots out of every 10 that he shot. We then ran a t-test with a confidence level of 90%, and the p-value we received was 0.01562, which is significantly less than the p-value of 0.1 needed to reject the null hypothesis. Thus, we can conclusively reject our null hypothesis and prove that males do shoot better than females.
This issue has been around for a long time, so what else can we do?
Boss, how about we lower the rim or we decrease the distance from the 3-point line to the free throw line, or we can even decrease the ball size. That will increase our shooting percentages. So we've identified 3 independent variables of rim height, field size and ball size, which affect our dependent variable of shot scored with room for error. Our assumptions made are that the smaller the rim size, the smaller the rim height, the smaller the field size and the smaller the ball size will increase the number of shots scored. So R squared value is the proportion of the variation in the dependent variable that is predictable from the independent variable. So we have identified our R squared value to be 0.7289, which is close enough to 1, indicating that our regression line is a good fit, and there is a significant correlation between our independent variables and our dependent variable. Hence, our independent variables chosen are suitable.
Boss, we can run a regression to test the efficacy of Glendon's propositions and see which idea we should implement. Okay. So as you can see, reducing the rim height and field size will result in the increase in shots scored, whereas reducing the ball size will decrease the number of shots scored. Thus, I believe we should not touch the ball size and only affect the rim height and field size. As you can see from the coefficients, the coefficient for the rim height is the most negative at negative 0.4672. This means that a change in the rim height will give the most results for the number of shots scored. If you look here, our rim height is 10 feet, field size is 16 feet, and ball size 7, will give us a shot scored of 4.1135. With all else being equal, if our rim height is 8 feet, it will give us a shot scored of 5.0479.
Okay, I'll send out an official notice tomorrow. Thanks, guys.
What you've seen in the video thus far was a story of a fictional team running an experiment and using the power of statistics to prove their assumptions, as well as identify solutions in order to solve their organizational problem. We hope that through this video we've illustrated how useful statistics can be in solving real-world problems and the various applications. However, here are some key takeaways we've discovered. Let's take our case of rim height for example. While the statistics show that an 8-foot rim will result in higher shots made compared to a 9-foot rim, we ultimately used our own personal considerations and decided to use the 9-foot rim instead, for the sake of maintaining the competitive and challenging nature of basketball. An example we can compare to would be the case of a marketing firm trying to figure out the best form of marketing that may have to utilize considerations due to budget or time constraints. As with the ball size, while we assumed that reducing the ball size would increase the number of made shots, the opposite was true instead. We assumed that this contradictory data is due to the fact that the players were not used to the smaller ball size, and it shows that sometimes the data collected does not follow the assumptions made. In cases like this, critical thinking is of utmost importance to think of reasons why the data is different from what we expected, and this enhances our solution process. Hope you guys enjoyed the video.